Ladies and gentlemen, we present to your attention a report on the topic Research of Effectiveness of Wood Fire Protection by Modified Epoxy Polymers. Providing of fire protection for wood using modified epoxy composition today is a prospective area of research. Modification of epoxy polymers is achieved by the introduction of the fire retardants, dispersed mineral fillers and additives that regulate the properties of materials. The analysis of these components' effect on the flammability of epoxy polymers, their flame retardant technological and operational properties, is an important scientific and practical task. Compositions based on epoxy resin ED20, carried by the amine type hydrogen monocyanethyl diethyl triamine MDATA, were used as a research object. To control the flammability and operational properties of epoxy polymers, basal scales activated at increased temperatures ABS and monoammonium phosphate MAP with a practical size of 5063 micrometer were used, as well as transition metal oxides as modifying additives vanadium oxide, copper oxide and zinc oxide. Researched compositions of epoxy resin are presented in Table 1. To determine the flammability of the research samples was used the oxygen index or I method. In the study on a series of 5 samples, the minimum oxygen concentration of the oxygen-nitrogen mixture were determined necessary to maintain stable combustion of these samples. The effectiveness of the flame retardant effect of the developed materials as wood coating was determined by the method. The method determined the loss of wood mass during the fire test in a ceramic pipe under conditions conducive to the accumulation of heat. The tests were carried out on 10 samples of pine wood, treated with the studied compounds and placed in a chamber with a temperature of 200 degrees Celsius. In addition, the self-ignition temperature of fire retardant coatings with various contents of modifying additives was determined according to ISO 871-2006. The tests were carried out according to standard methods. To determine the self-ignition temperature, samples of epoxy composition weighing 3 grams were used. The research results are presented in Table 2. As can be seen from Table 2, the modification of the epoxy polymer with activated basal scales and monoammonium phosphate composition ERM transforms the ER coating from the class of combustible material into self-extinguishing OI 27%. Self-ignition temperature of this composition is 525 degrees Celsius. Testing in accordance of wood samples treated with the tested compound shows that this coating provides first group of fire retardant efficiency with an average weight loss of 70.2%. Modification of the ERM composition with transition metal oxides increase the flammability of the coating to oxygen index values of 25, 26 and 23% for ERMB, ERMC and ERMZ composition accordingly. But at the same time, the average weight loss of samples accordingly decreases and is 4.85, 2.21 and 3.17 for composition ERMB, ERMC and ERMZ. Comparison with similar coatings applicable for wood-based fire protection allow us to state the effectiveness of the use of transition metal valence oxides in combination with ABS and MAP for epoxy compositions. The data in Table 2 show that according to the efficiency of increasing the self-ignition temperature of the epoxy composition ERM, transition metal oxides can be arranged in the following sequence: zinc oxide, vanadium oxide, copper oxide. Conclusions. Monoammonium phosphate and activated basal scales used in the composition of epoxy resin makes it possible to obtain a fire retardant coating for wood with good performance and reduced combustibility. Especially the effect is enhanced especially when used together with transition metal valences. The most effective modifying additive is copper oxide. As a result of researches, it was found that in terms of the effectiveness of the fire protection, the developed fire retardant coating corresponds to Group 1 of fire retardant efficiency for wood, and the weight loss of the tested samples is on average 2.21%. Thank you for your attention.